Okay, so we've got question 1 here. Let me try and get it in the screen. All right, so if we use what we know, they want, it's a parabola opening up, and we can see it's going to be a negative times x to an even power, so it's going to have end behavior down, down. So it's going to look like that. So it's going to be opening down. So I'm just going to type in down here. And then what are the x-intercepts? Okay. If I'm going to find the x-intercepts, then I need to set this equal to 0. So instead of f of x, I'm going to replace that with 0. I don't like when I'm solving for zeros to have the first term negative, so I'm going to multiply everything by -1. And so I'm going to have 0 is equal now to positive x squared minus 4x plus minus 77. Now, if I want to factor this, I need to find two numbers that multiply together to give me -77, but at the same time add up to give me -4. I know that 77 is 11 times 7, so -11 and +7 should do it. -11 times 7 is -77, and -11 plus 7 is -4. And I can see that the zeros here are 11 and -7, and those are real numbers, and so I will get x-intercepts from them. Now, the instructions say to give the smaller one first, so I'm going to have that as my x-intercept, so I'm going to type that in as well. Okay. Now for the y-intercept, well, the y-intercept, there's two ways of getting it. When it's in this form, the y-intercept is just the constant term. So the y-intercept is going to be the point 0, 77. Or, same thing, the y-intercept is found at f evaluated at 0. And of course, these terms go away and I get 77. So the y-intercept is going to be the point 0, 77. Okay, and now the vertex. Well, the x-intercept of the vertex is going to be -b over 2a. And here we can see that b is 4 and a is equal to -1. So this is going to be the negative of b all over 2 times a. So these two negative signs are going to cancel. I'm going to end up 4 over 2 is equal to 2. So for the vertex, its x coordinate is going to be equal to 2. Now what's the y coordinate? Well, it's going to be f evaluated at 2. So I'm going to come back up here, and if I want to evaluate f at 2, I'm going to have this. All right. 2 squared is 4, so I'll have -4 plus 8 plus 77, and that's going to give me +4 plus 77, which is going to give me 81. So 2 comma 81 is going to be my vertex. my bad. And finally, the vertex is a minimum or a maximum. Well, we had up at the top there that our end behavior was down, down, so this thing opens down, and so our vertex is going to be a maximum. All right, now let's just see if we can confirm this on the calculator. I'll put this in negative x squared plus 4x plus 77. Now, the window we want to take, well, we want to see the vertex, which is at 2, 81, and we want to see the x-intercepts. So I'm thinking, and the y-intercepts. So I'm thinking maybe negative 10 to say positive 15, because I want to see the x-intercept at 11. And the y minimum will go from negative 10, say, up to 90. And I should be able to see, then I'm going to press graph. I should be able to see everything there. Okay, so we can see we've got an x-intercept at negative 7 and one at positive 11. And a y-intercept at 0, 77, and the vertex is going to be at 2, 81, so that's looking good. All right, so I'm happy with that answer. All right, so let's go on to the next question. Let's do synthetic division. Now we want to divide this by x minus 2, so we're testing to see if 2 is a 0. Remember, if 2 is a 0, x minus 2 is a factor. So it's x minus the number in the box, or the potential 0. Now we have to be careful here, because the coefficient for x to the 5th is 1, but for x to the 4th is 0. Okay, now that I've supplied all the powers there, I should be able to set this up correctly now. 1 times the number in the box, then we add. 2 times the number in the box, then we add. 5 times the number in the box, then we add. 10 times the number in the box, and then we add. 20 times the number in the box, and then we add. So this is my remainder. Okay, so none of these other ones are going to be it. And then here is my quotient. These are the coefficients for my quotient. And I'm going to start at the bar. This is my constant. That's my coefficient for x, x squared, x cubed, x to the 4th. Keep going till you run out. So my quotient is going to be 1 times x to the 4th plus 2x cubed plus 5x squared. And that rules this one out. All right, so it's going to be this one, plus 10x plus 20. That's my quotient. Okay. So it's going to be our first one there. Okay. Let's divide the polynomial by x minus 4, so it is x minus the number in the box. I meant to do that in black. And I have 1 times x cubed, 2 times x squared, 4 times x, and then 4. 1 times the number in the box, then we add 6 times the number in the box, then we add 28 times the number in the box, okay. And then we add. So this is my remainder, and this is my quotient, the coefficients for my quotient. So I start here at the line. That's my constant, my coefficient for x, my coefficient for x squared. So I can write p of x as the divisor times the quotient plus the remainder, which is going to be, the divisor is x minus the number in the box, or what you divide it by, times the quotient, 1 times x squared plus 6x plus 28 plus the remainder. Now, none of my answers look like this. None of my answers look like that. So there's a second way that you can do that, and this was done in one of the videos. You're taking p of x and you're dividing it by x minus 4. So I'm going to divide every term over here by x minus 4. And as you can see here, because we've got multiplication in the numerator, the x minus 4's cancel. And so I'm going to be left with x squared plus 6x plus 28, and then plus 116 over x minus 4. Okay, so it looks like it's going to be that first one there. All right, so the polynomial is divided by x minus 5. So x minus the number in the box, and we're told that the remainder is 2. So by the remainder theorem, we have p evaluated at the number in the box is equal to the remainder. And so 5 is not a 0. If 5 was a 0, then p evaluated at 5 would be equal to 0. Because the definition of a 0 is some number c such that p evaluated at c is equal to 0. This is not equal to 0. It's equal to 2. So 5 is not a 0. If it's not a 0, then x minus 5 is not a factor. Okay. So I'm looking for 5 is not a 0. So that says 5 is a 0. That doesn't mean anything. 5 is not a 0. And x minus 5 is not a factor. So I want that third one there. Okay, now what's the end behavior? Well, the leading term determines the end behavior. We can see we have a negative number times x to the, and this number ends in 1, so that's an odd power. And if you have a negative number times x to an odd power, your end behavior is up, down. So there's 4 cases that you'll have to know. If you put that into your graphing calculator, you're not going to get anything in your window that looks like anything. So I'm looking for up to the left, down to the right. So I'm looking for that first one there. Okay, let's look at this one. What are the zeros? All right, well, let's look at the graph. We could try and group that, factor it by grouping. We could. But I'm thinking, look at the choices here. I'm betting 3 is a 0. Let's have a look at the graph. Since the degree is 3, we will have 3 zeros. So let's have 9x cubed minus 27x squared minus x plus 3. And let's start with a zoom 6. And I can see that 3 is a 0, just if I look at the graph. Try that. I'll just change it. There's 3. It's going through 3. Then if I do second graph, you can see that the point 3 comma 0, well, 3 is an x-intercept, and so we have a 0. So 3 is a 0. So immediately I can rule this one out here, saying that there are no zeros. So 3 is a 0. Now, what's going to happen there? Let's look at the graph. All right, I have 3 distinct real zeros because I have 3 distinct x-intercepts. So there, there, and there. So I will have 3 distinct x-intercepts, so there's 3 real zeros. So we're not going to have this one because you would only see the 3 on the x-axis and you wouldn't see anything else because it has an I in it. They don't give you x-intercepts. And same here. Okay. Now that could be it. This could be at 1/3 and negative 1/3. This is saying you just have 1, 0, 3, but it's repeated 3 times. But you can see you have 3 distinct x-intercepts. So what I'm going to do is I'm going to use synthetic division, and I'm going to use synthetic division with 3 because I want to test the 0, 3. Okay, so put that in there. And this will give me the way to do it. All right, 9 times the number in the box. And we add and get 0. 0 times the number in the box. And we add and we get negative 1. Negative 1 times the number in the box is that. And we add and we get 0. Now my remainder is 0. So x minus 3 is a factor. 3 is a 0. And I can write f of x as the divisor, x minus the number in the box, times the quotient. And I start here at the line. That's my constant. That's my term for x. It's my term for x squared. So I'm going to have 9x squared minus 1 plus the remainder plus 0. So I'm just going to leave it like that. And I can factor that because 9 is 3 squared. So inside there, I'll have that. And so I'm going to get the first one minus the second one times the first one plus the second one. Okay, so that should work. If I FOIL that, I'll get 9x squared plus 3x minus 3x, so they cancel, and then minus 1. Okay, and now we can see what the zeros are. Set that equal to 0. 3 is a 0. 1/3 is a 0, because 3 times a third is 1, and 1 minus 1 makes the whole thing 0. And negative 1/3 is a 0. If x is negative 1/3, then I'm going to have negative 1 plus 1. Okay, so I want that one there. Okay. All right, so the first thing I see here is that they have a 0 in common. Sorry, they have an x in common, my bad. So I'm going to factor that out. And let's look at this one on graph. So I'm going to have x to the fourth plus 10x squared plus 9. Okay, and I'm just going to do zoom 6. Okay, zoom 6 is not telling me much. Okay. All right, fair enough. Well, when we have something like this, I can see that 1 is not a 0 because the point 1 comma 20 is on the graph. And so this is saying that 1 and negative 1 are zeros, so that's not going to happen. Okay, I can also see that 0 is going to be a 0. Because if I put this equal to 0, then you can see if x itself is 0, that'll make the whole thing 0. Okay, so this one does not include 0. Okay. And if 3 and negative 3 were zeros, I would have x-intercepts at 3 and negative 3. And you can see you don't have an x-intercept at 3 because the point 3 comma 180 is on it. So it's not going to be that one either. Okay, so it's just down to these. Okay, so when you've got something like this, you want to try and factor that. So you may or may not have learned this trick in high school. If I'm going to factor that there, let's let u equal x squared. Then you can factor this. So u squared is equal to x squared all squared, which is x to the fourth. So we can rewrite this as u squared plus 10 times u plus 9. And that will factor, because 9 times 1 is 9, and 9 plus 1 is 10. And so we've got, now get it back to x. Now, if you have x squared plus a number, any number, that always factors. It's going to be x minus the square root of k times I times x plus the square root of k times I. So here I'm going to have x minus the square root of 9 times I plus times x plus the square root of 9 times I. And then this one here will be x minus the square root of 1 times I, and then times x plus the square root of 1 times I. Okay. And finally, I can solve for x. What will make that 0? If x is 3i, minus 3i, I, and negative I. Now, these are complex numbers. You do not get x-intercepts at complex numbers. So you could rule this one out because it had x-intercepts with I in it. And from that alone, we actually wouldn't have had to do that substitution. We would have had the only x-intercept is 0, 0, because 0 is the only real 0. So I'm going to have that one there. Let's keep going. We have a polynomial of degree 3 whose coefficients are real numbers. So we're going to have 3 zeros if we count any repeated zeros. And we know that one of them is 4, and one of them is -5 minus 3i. Well, this is a non-trivial complex number, so the other one is going to be the complex conjugate of it. Now, what's the complex conjugate of that? Well, with a complex number, you change the sign of the number that's multiplied by I. That's the only thing that changes. So that's the answer I am looking for. This one here. Okay. All right, so this is a rational zeros theorem. So we can see here P is equal to -4 and Q is equal to 6. And try it again. Let's try it one more time. It's going to be, P is going to be, I got them mixed up, and that is so easy to do. So all of my choices for P over Q, the factors of 6 are going to be 1, 2, 3, and 6. And the factors of 2 are going to be, of -4 are going to be 1, 2, and 4. Okay. So I'm going to have plus or minus 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Then 1 over 2, 2 over 2, which reduces to 1, 3 over 2, and 6 over 2, which reduces to 3. And finally 1 over 4, 2 over 4, which reduces to 1/2, and 3 over 4. And then 6 over 4, which reduces to 3 over 2, which is already in my list. Okay, so I want plus or minus 1, 2, 3, and 6. 1, 2, 3, and 6. That's in the running. 1, 2, 3. All right, that has the 4 in there, which should not be there. 1, 2, 3, and 6. Okay. And then I need 1/4, 1/2, 2/3, 3/4, and 3/2. No, I don't have 2/3 in my list. I do not have 2/3 in my list. So my fractions are going to be 1/4. Yeah, it's in my list. 1/2 is in my list. 3/4 and 3/2. Okay, so it should be that last one there. All right, let's look at this one. Okay, so here we want A intersect B. So A intersect B. 1, 2, 3, 5, 8 is A, and intersect B. So the intersection is only the stuff that's contained in both. So 1 is not contained in both. 2 is contained in both. 3 is contained in both. 5 is contained in both. 8 is not contained in both. And once you've gone through everything in the first set, you're done, because it has to be in both sets. So I'm looking for 2, 3, and 5, which is in the last one. Okay. Now the union is either one. So you're going to take A and C and make one great big set out of it. So I'm going to write down A and then include C in the same set. Now the only thing is, with set notation, you cannot have duplicates. So I have a 1 here and a 1 there, so I just need to eliminate one of them. And have a 2, it's not repeated. A 3 is not. And then what they usually do is they'll write stuff in order. So, oh, that's really bad. Let's try that again. So I'll have 1, then 2, then 3, then 4, then 5, then 8, then 9. So 1, 2, 3, 4, 5, 8, and 9. It's looking like that one there. Okay. Now there's different ways for writing the complement. They want you to get the complement of A union B, or this could have been written with a little C up here, or this could have been written with like this asterisk mark or apostrophe. All of these mean the complement, and different textbooks use different ways. All right, well, the first thing we have to do is get A union B. And so A union B is just going to be one set. So let me write all of that down. There's A, and put B into one set, but you cannot have duplicates. So I've got 1, then I've got 2, then we've got 3, there's not a 4, we've got 5, there's not a 6, there is a 7, and then finally an 8. So that's what A union B would look like, but now we want the complement of it. So you're going to take your universal set, which is U, and you're going to subtract or get rid of everything that's in A union B. So I'm going to take my universal set and I'm going to get rid of 1. I'm going to take my universal set and get rid of 2. I'm going to get rid of 3. I'm going to get rid of 5. I'm going to get rid of 7. And I'm going to get rid of 8. And then what's left is going to be what we have: 0, 4, 6, and 9, which is going to be that one there. Okay. Now let me go down here. All right. With the number of possible positive real zeros, I don't have to change anything here. I just count the number of changes inside. So I go from positive to negative. That's one change. sorry, I go from negative to positive, that's a change, one change. I go from positive to positive, no change. Positive to negative, that's another change, it's my second change. Negative to positive is my third change, and positive to positive. So in total, I have 3 changes. So I will have 3 changes of sign, or you keep subtracting 2. 3 minus 2 is 1. So I'm going to have 3 or 1 changes of sign. Okay. Now, for Descartes' rule, what are the number of possible negative real zeros? Okay. Well, the first thing we're going to have to do is to get the formula for f of negative x. Now, you don't just negate, change the sign out the front of all of these. It's not what you do. If the power is even, which it is here, this stays the same. It does not change. The power here is even, so it stays the same. The power here is odd, so the sign out the front changes. The power is even, so everything stays the same. And I have 4x, which is the same as 4x to the first power. 1 is odd, so this sign out the front changes. And of course, the constant always stays the same. So now count up the number of changes in sign for that. Negative to positive is 1 change. Positive to negative is another change. Negative to negative, no change. Negative to negative, no change. Negative to negative, no change. So we will have 2, or you keep subtracting 2, or no real zeros. All right, this is not even. If it was even, it would be symmetric with the y-axis. So if we were starting over here, then its reflection would look something like that. And that's not what we get, so it's not even. It's not odd, because if you were to flip that upside down, then the graph you would get would look like that. And that's not the same, the exact same graph. So this one's going to be neither. All right. Okay, so the center is called H comma K, and the radius is R. So you can write it in standard form as x minus h all squared plus y minus k all squared equals r squared. So we're going to have x minus h, so h is negative 7 all squared, plus y minus k, and k is 0, is equal to r squared. Okay, so here we're going to have x plus 7 all squared. Okay, so we can rule this one out and that one out. And then plus, well, y minus 0 is y, so that's just going to be y squared, is equal to, and the square root of 17 all squared is, well, the square root and the square undo each other. So that's what I'm looking for. And this is the one I want, so it's going to be the one at the end. That has a minus sign there, and that's not correct. That's the one we want. Find the center here. Okay, so we're going to have to complete the square. All right, so what I'll probably do is get these over to the other side. So I'm going to subtract 17 from both sides. Okay, so 36 minus 17. 16 minus 7 is 9, and 2 minus 1 is going to give me 19. Those are gone. Okay. Now I have to complete the square. So I'm going to take this, divide it by 2, and square. 8 divided by 2 is 4, and 4 squared is 16. Okay, it actually was already in the form that we needed. I'm going to take that, divide it by 2, and square it. And negative 1 squared is 1. Okay, so this one was actually already set up for us, so I could go ahead and just put them like this. Okay, without having to put the constant to the other side. Usually they won't have it that nice for you. This can be factored. Two numbers that multiply together to give me 16, but at the same time add up together to give me 8. Well, 4 and 4. And two numbers that add up to multiply together to give me 1, positive 1, but add up together to give me negative 2, and that would be negative 1 and negative 1. And 36 is 6 squared. Okay, so we just want to rewrite that. X plus 4 is the same as x minus negative 4. And I'll just have y minus 1 there. Okay, so that's going to be my h. That is going to be my k. That's going to be my r. So h comma k is going to be negative 4 comma positive 1. And my radius is going to be 6. So I'm looking at that one there. All right, let's get back to this one here. So in a right triangle, okay, we've been told we have a right triangle. Okay. The first leg has length 35, which is 2 less than the length of the hypotenuse. So there's a leg, and this is the hypotenuse here, across from the right angle. And so the hypotenuse is going to be 2 more than 35. Okay. What is the length of the second leg? So I'm going to want to find x here. So from the Pythagorean theorem, we'll have x squared plus 35 squared is equal to 37 squared. And so x squared is going to be equal to 37 squared minus 35 squared. And so we'll do that now. So 37 squared minus 35 squared is 144. Now, if I take square roots of both sides, then I get x is equal to plus or minus the square root of 144, which is plus or minus 12. But this is the side of a triangle, and so it has positive length, so I'm going to choose x to be positive 12. All right, and finally, Bob Gromsky wants to build a rectangular building. Okay, so here's a rectangle. And the perimeter will be 400 feet. So if I call these sides the width and that side the length, then the perimeter is 400. And so the perimeter is like a fence. If I add all these different sides up, I'll get width plus length plus width plus length. And so I have 2 times the width plus 2 times the length is equal to 400. So that's one formula I have. And the length is 10 feet fewer than the width. Okay. So it's going to be W minus 10. The length is 10 feet fewer than the width. Okay. So I'm going to go back to this formula. And instead of L, I'm going to have W minus 10. Two W plus 2W is 4W. And I'm going to add 20 to both sides. And then I'm going to divide both sides by 4. And I'm going to get the width. Okay, so 105. Okay, and that completes this test, my test bank for test 4. Okay, I was about to click submit, and when I was scrolling down, I must have scrolled too fast and went past question 16. It's telling me I didn't submit 16. So, okay, let's have a look. Let's look at that. Clear that out. I'm going to have negative 2x cubed. Now I'm going to start with a zoom 6. All right, that looks like it's going to be odd to me. So if I had a physical calculator and took that and turned it upside down, it would look like I'd get the exact same thing. But, you know, really improve that standard window. Okay, so if I was able to turn that upside down, I would be getting the exact same thing, graph, and that means it's going to be odd. Okay, so I think I've gotten all of them now.